Hey, what's going on, guys? Pierre here. Today we are going to so today is a development video, so I'm just going to fix an issue and just record the process, I guess. So this is this new issue here. Deleting a sub-assembly doesn't delete the connecting joint with parent assembly. So okay, so since this pull request, fixed the fact that when you deleted a component in assembly, the related joints were being removed. So it was fixing it. But anyway, so this is passed, and now it's not working with the new sub-assemblies. Okay, so there's a video, and if we check, yeah, so he then deletes subassembly 2 here, which is an assembly link object, and then fixed 001 is not getting deleted. So first we're going to make a file, very simple file to reproduce this issue. So we have assembly here. We are going to put a bunch of boxes, stuff. Okay, so we have here we have one cube. Okay, and then in the second assembly we have one cylinder. No, we have the cylinder, and this is the other. Okay, so now we are going to insert a link to, and a rigid one to assembly, I guess. And now we are going to hide the original assembly. And so now in this assembly we have a link to oh, it fixed it. Well, we are going to unfix it. Oh wait, we are not going to unfix it because we are trying to see if it's removing those correctly. So if I create a joint here, let's go. We create a joint, cylindrical revolute joint. So it's working. You see we have here revolute joint, and let's have a look at the references. We have assembly face assembly 001, so this is it. Okay, no, this is this cylinder, and this is assembly 1 assembly 2 dot face. Okay, so the joint looks correct, it's working correctly, good. Now we are going to save this and sub ISM bug. Okay, so now what happens if I remove this? Well, that works. Okay, and I even have a print of on delete. Well, maybe, yeah, that's probably a development leftover from my other PR. So let's see, we have, okay, so it works. Here it works. So I guess it has to be a flexible subassembly for it. Yeah, you see it's a flexible subassembly in this example. Let's see, subassembly 2. Yeah, it's not rigid. So I guess the bug happens if the assembly is not rigid. So we can right click, turn flexible. Okay, and then the grounded joint is going to be broken, and so we have one ball here. We have the revolute joint which is holding these two components together, and so you see I have here the box sphere. Okay, now if I ground the box, okay, now this joint should work, and it is working, right? And this is, well, this does not matter. Fine, now let's try again and see if it is now failing. So I save, and then I'm going to delete this, and yeah, we have the joints which have not been removed. So it's only for flexible subassemblies. Maybe I even mentioned it in the rigid, flexible. No, it does not mention it. But anyway, so this bug happens only fine. Just letting people know I'm currently on it. Okay. So that's for flexible subassemblies. So yes, I made the screen much smaller for the recording of the video. So that's why it's kind of squished. But let's see, we are going to just make this big. This we don't need. I will leave it. So what happens when I delete a component of the assembly? I don't remember actually. I think we are calling on can delete or maybe on delete. Yeah, I think it's this on delete. Delete the assembly groups when assembly is deleted. No, that's not it. It's when the wait a moment. When is it? No. Oh yeah, it's here. It's in can delete, I guess. Let's see. If a component is deleted, then we delete all joints as well. Right. So when you delete something in the assembly container, this function is going to be triggered, and it will say if what happens, right? So if a component is deleted, then we delete all the joints as well. So assembly part, so this is just, okay, object to delete, list its joints, okay, list its joints, list its grounded joints, okay. Let's see, joints equals assembly get. So we are making a list of its joints. And the problem, I guess the problem is that, so when we are deleting a flexible subassembly, the joints are not on the subassembly, they are on the links which are inside the subassembly. And so this is failing, and delete them. Okay, so we are going to just have a look at this one here, or maybe even we can start with this one. It's maybe easier. So we have object, which is not going to be the subassembly. Yeah, so that's what is tricky here, is that the grounded joint, for example, is not linking to the assembly, it's linking to box 001 directly. So this is why it's not detecting, because here it's the subassembly, right? It's not. Whereas if you have one rigid subassembly, so if I insert a rigid subassembly of this one, so this one is a rigid one. If I ground this one, then it's the whole subassembly that is grounded, right? But okay, so I guess there is several possibilities here, several solutions possible. One is to change the way we are currently dealing with the joints, because we could just delete the object and then check if the joints are still correct, and if they are not correct, remove the joint, right? If the link is broken, remove the joint, like if the object is lost, instead of trying to delete the appropriate joints. Yeah, I think this is much better, because then we are not, because here when we are doing it like we are currently doing it, which is basically we look at the object that is being deleted, and then we try to find all the joints and we delete those. The problem is that we may miss some things. For example, here the flexible subassemblies, right? For example, this bug. So what we can do instead is remove the object and then make a check on all the joints of the assembly and just check if they are still valid. And if they are not valid, we just remove it. And this way we are sure we are not missing something. The downside is that if a joint is not complete, or if a joint is broken, and if it's for something unrelated, then it's getting removed. So I don't know. And the other possibility, I guess, is that we can detect the case where the object being deleted. So here we can add one test to check if object is a subassembly object, and if so, we make sure that we are doing this for all the components inside the subassembly, which is fine, I guess. It's totally possible as well. So we have two possibilities. Okay, so I think I may go for the second one, because the first one, like, you're removing all the joints that are not valid, but maybe the user has one joint that is not valid and he wanted to keep it because he's going to change the reference or something. So it's more invasive, and the second solution is less invasive. So yeah, I think we are going to do this. Okay, so good. So we are going to change. Okay, so what do we need to do? What do we need to do actually? What to do? So we need to have a recursive function that will just tag all the components of subassemblies, because the subassemblies, the assembly links, they can be nested, right? So, oh, but they can be nested, but I'm not sure we can have nested flexible subassemblies actually. But even if we don't, it's a feature request that is going to be asked. So let's consider that we actually have nested flexible subassemblies. And if we have those, then we need a recursive function, right? Because there is an undefined number depth of flexible subassemblies, potential flexible subassemblies, right? So let us summarize. What we need to do here is to add okay, so here assembly link, and we are going to put dynamic cast, so we are going to try if ASM link. So assembly link is apparently not. Oh yeah, we are in assembly link. Okay, assembly link is not included apparently. I think. Where is it? Here, assembly object, assembly link, and well, I think assembly link is actually linking to assembly object. Oh no, it's not. Well, never mind. Okay, so we have assembly link. So we are casting assembly link. And if object, so if ASM link and ASM link is rigid, is rigid, and not is rigid, of course. And so if we have an assembly link okay, and so what do we do? We need to get to have the components, right? Let us think. We need the components, but how do we get the components of an assembly link? I don't think I made a function for this. Let us have a look. Is rigid, update content, synchronize, blah blah blah. So no, we don't have any component getting function, I guess. Synchronize components. So synchronize component is synchronizing. So assembly group, assembly link group. It's so what we are doing is getting the group, okay, assembly link group, but then how do we do for object 2 in assembly group? Linked objects as blah 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 blah. We consider only links and assembly link in the assembly link. Well, that makes sense. Okay, yeah, we are going to do something like this, right? So we need to take this and we're going to put it somewhere here, for instance, and then go back. Oh no, I lost it. Where is my... Oh, here. Good. So we are going to do something like this. Assembly link group, and then assembly link group dot get value. Okay, so now we are checking. So we are going to browse the objects within the subassembly, right? And we are going to consider only the sub-assemblies and the links, because links are going to be links to objects. If you look at this subassembly, for instance, you see we have links to objects, and basically we just want to filter the origin and the join group. So we only want, yeah, the links and potentially sublinks, right? Because they could be nested. So what we do is that we are doing a dynamic cast to see. So if sub-assembly or, because we are going to do the same for both, else continue, not recursive. So the false comment is not recursive, get linked object to. Right. But we don't want that, actually. We don't care about that. What am I doing? Sometimes you just go so far and then you forget what you are currently doing. Object to delete. Right, so this here, this listing the joints, listing the grounded joints, and then deleting all of this block, we actually want to do it for all the objects that are being deleted. And so not only the objects, but maybe there are more, right? So this block here should actually be in a for loop. So we are going to take this and put it in a for loop, right? And the for loop is going to be so we need we need a vector which is called object being deleted, because an object to delete is actually the joints that we want to delete, so it's different, right? So now we want like a for loop on this. So for auto object being deleted. Yeah, let me put a S here. Objects being deleted, something like this. So for each object being deleted, we need to replace the objects that are everywhere. Obj, and then joint. Wait a moment. Oh no, deleting the joints needs to happen outside of this block, because it's actually like we are making the list of joints and then we are deleting all the joints at the same time, right? So yeah, so that's it. So, but this is annoying. Yeah, this is annoying. So let us call this obj because it's too long and it's going to blunder the syntax. And instead, this is here that we are going to obj being deleted here, and we are going to remove here, here, and then here. Let's see. So the next obj is here, and then obj. Okay, so this is fine. So this is not going to be changed. This is okay. Listed joins. This is not going to be modified actually. And so now what we need to do is to populate this vector of object. So first thing first, I'm going to add the object itself. So push back. Ah, come on, autocomplete is annoying. We never. And now object being deleted, we push back this, right, to start. And let us just change the order here, like this. Okay. So now we want to add this, right? Because this is what we are here for. And here we can call this obj. We don't need the two. And we don't need, yeah, so we just remove this. Else, we don't need the else, we just need this. Okay, so now the problem is that this is not recursive. So we need to make it recursive. To do this, what are we going to do? Let me think just 1 second. So object, so first we add the subassembly in here, then we go inside the subassembly and we add the components. So this is fine. And then if subassembly, we need to do a recursive call add subcomponents. Add subcomponents of this, and then it's going to need the vector of object being deleted. Basically, we just need to make a lambda now, a lambda of, yeah, we need a lambda here, some kind of lambda. Well, you know what, for this, because recursive functions can be a bit tricky well, not tricky, but just, they can be hard to understand and easy to mess up. So what we can do is to use ChatGPT, but first I'm looking at this, and this means there is a problem in my syntax somewhere. So I'm going to tackle this real quick. Oh, here it is. What is this? What am I doing? I think, yeah, this is correct now. Yeah, I think it is. Okay, so yeah, we are going to use ChatGPT to help us make let us see. Why is it not working anymore? Oh, I cannot use my history. Yeah, because I lost my plus membership, I guess. So now, oh, and when it's, oh, you cannot look at the history now if you don't have plus. Well, never mind. We're just going to ask it to write the lambda. Yeah, yeah, let's see what he comes up with to implement blah blah blah. So yeah, well, I could do it manually, I guess, but it's so powerful that it's easy to just be lazy. Especially the syntax of Lambda. I don't know why, but every time I just forget the syntax, which is annoying. Okay, let's see. If I put this here, assembly link, it takes an assembly link and then it takes a reference to a vector. So that sounds good. Assembly link group, and so basically, what is it doing? Why is it? Well, this is not good. Let me think. Why? Why is it a variable declared with an autotype specifier cannot appear in its own? Yeah, I think it's just this. Yeah. No. Damn. Let us. Cannot. And here you cannot select, huh? Right? This is so annoying. Cannot appear in its own. Cannot appear in its own no, in its own what? Initializer. If full update code context, I have this error, blah blah blah. This occurs in the lambda you are trying to define and immediately use it, blah blah blah, as a standard function before the lambda assignment. Include functional. What is it? Plumbering. What? Well, I've seen already recursive functions that looks better than this. But I just keep forgetting them. When have I done this before? When have I done this before? Standard function. When have I done this before? Because I remember that it was easier than that to use, to write. Yeah, it was definitely easier to do, I think. Oh, this is annoying me a lot. When I cannot find, like, when I was actually doing something, like I cannot remember in which PR and where in this damn code I have been doing this, and this is just annoying. Well, it seems to be accepting this, but you know, it's yeah, whatever. So this is very long, this name. Let's just call it ouch. Because okay, let us make sure it's doing what it's supposed to do. So it's taking the assembly link and the list of objects being deleted, and what is it doing? It's getting the group, and then it's iterating the group and putting inside everything. Oh, so it's not good. You see, you have to check. If you don't check with ChatGPT, then you have then you get something stupid. Yeah, if you don't look, you get something stupid. Stupido. And don't care about checking duplicates because we should not be able to get duplicates actually. Well, I can still leave that on, I guess. Yeah, it does not cost that much to check for duplicates, I guess. And maybe this inside here. I guess, yeah. So, does that now looks correct? Yes, I think it looks correct. So I can just use here. I can just, no, use here like this, like, and then here, this, and remove that. No, not this, yes. So, okay, so now I'm populating all the objects that are being removed, and then I list their joins, make a big list of joins, and then I remove all the joins here. So I think that should work. Let us just review this one more time. So if assembly link is, if the object to delete is an assembly link and it is not a rigid one, then we are adding sub-components. So we pass the vector of object being deleted, to which we are going to add more, and assembly link, and we are doing group, we are getting the group, and then we are checking if these are, we are not checking, oh yeah, we are not checking if it's rigid. If it's not rigid, then we should not, yeah, if it's not rigid, then we add subcomponents. If it's rigid, we don't need to. And if it's already in, that means that we don't need to do this as like this. Okay. Because this, I think this is kind of optional, right? It's because we should not be able to get duplicates while browsing groups, because an object cannot be in more than one group. Well, it doesn't hurt, we never know. Okay, so I think now it's correct, right? We are doing only for rigid, for flexible subassemblies, and yeah, I think if I build now, let us first make sure I have this saved. And close, and then we build, and I think that will be it, and it will be a 30 minutes video, so not that long. So if you have any comment on the video content and what you'd like to see, or what you'd like me to explain more, or I don't know, you know, I'm just making this video because it does not cost me anything and just allow me to share some content about the source code of FreeCAD, which may be useful for someone who want to pick it up. So, you know, if it's useful to someone, that's great. If it's not useful, it's not a big deal. So that's why I'm doing this, right? But if you want something special, like, and it's within my ability, I will try to provide, I guess. And also, while it's building, I'd like to mention that if you like what I'm doing in FreeCAD, you can maybe consider supporting me on Patreon. If I can make a living with developing in FreeCAD, then I can, you know, spend more time and so on. So, and if you're already a contributor, then thanks very much, right? It means a lot to me. and being able to work on FreeCAD is really cool. Like building in open source, something really cool like FreeCAD is really awesome. So yeah, that's it. So let's see. We have this, so this should still work. Let's see. Yeah, that still works. Now if I go in here, I take this and I remove it. Now that works. Great. Now let's we have a warning here. Link to box 001 go out of scope. I'm not sure it's related to what we have been doing here. Yeah, I don't think so. So I think that's about it. So I'm just going to wrap up here to make the PR. So you see the changes, I actually made them in a branch, which was another fix, and we don't really want that. So I'm going to stash the changes. So I'm going to do git stash, and then if I rescan, you see no more thing here, and I create a new branch based on main I said, and I call this ISM delete subassembly bug create. Okay, so now we are in the new branch. I then go back to the bash and I will git stash pop to get the changes back here, and now I can stage and put a commit message. So assembly fix joins not being deleted when subassembly is deleted. Wait a moment. Yeah, I think that's it. Commit. Rescan. So this was the pre-commit, so it's doing some stuff, right? Some formatting stuff. And then we stage again, commit again, click on push. I will push to Ansel because I'm still employed by Ansel for about 1 month. And then I go to GitHub, compare and pull request, fix joins, blah blah blah. So we can put this here, and then we are going to put deleting an exploded view. So now that's another bug. Where is my bug? Oh yeah, it's this one. Okay, well that's it from start to end, a bug fix. It was not too difficult, so it's good for a video because some bugs I can spend 4 hours just turning in circles. So this one was good for a video. Well, thanks for watching and have a good day. Bye bye.